Hey guys, and welcome to All About Studies. So, this is your physics teacher Harshal Shinde. And in the last video, we learned about potential difference, electric potential, its formulas, and also its SI units. So, today we are going to learn a very interesting and I think one of the most important concepts of this chapter, that is electric current. So, let me write it for you. So, electric current. So what is electric current? We all know that when we plug our chargers and in the socket, in the wall socket, and also connect the wire, that is the USB pin, into our mobile phones or even in our laptops, the laptop or the devices get starts getting charged. Now how it happens? Is there any magical power or something else? So what happens is that when we plug our charger and the USB pin into our devices, that circuit gets complete. And when we switch on, that is we turn the switch on, then the circuit gets complete. I mean, the circuit gets fully complete. Earlier it was complete, but however the key was not in it was open. So after the key is closed, that is the switch is on, then the electrons or the electric charges start flowing from the transformer or probably any generator or any source, for that matter any source, to our devices, and our devices gets starts getting charged. So here in this in the electric current, let's get to the chapter. So electric current refers to the flow of charges. It refers to a flow of charges in a conductor. It can be any kind, metal, non-metal. There are many non-metal conductors as well, like graphite. So there is an flow of electric charges in the conductors, which help them getting charged. So let me write it for you. That it refers to a flow of charges, flow of electric charges, to be very precise, electric charges in a conductor. Let me write it in this way: in the conductor. So this type of uh, okay, so this type of electric current, this type of flow of electric charges in a conductor is called as electric current. Electric current. So what happens? So what is the mechanism behind this whole electric current? So as for your understanding, let's take an example of water. Now you can do this activity at your home as well. Like take a glass of water, take a glass and then fill it with the water, and start flowing. I mean, start pouring the water into an open area, like for instance any particular ground, or wash basins. Start pouring the water. Now after doing this activity, what will be your observation? So observation will be that the water flows from its source to a empty space. Like you have observed while doing this activity, you may have observed that the water that is full of the glass that is full of water, in this the water molecules are flowing from the glass to the basin, to the wash basin, or any ground wherein there are absolutely no water molecules. So here, as you can see, that this particles are going from its reservoir or from its source to an empty space. So in the electric current as well, the electric charges are flowing from where it from its source or from the reservoir to a place where there are absolutely no electric charges. So this is actually a very for this can language can be used for your understanding, but as we all are studying science, physics to be precise, we have to speak or understand in the physics terminology. So in the physics terminology, how we can write is that the charges flow from uh, higher potential, that is the source or the reservoir of charges, higher potential to lower potential. So as I earlier gave the example of this of the devices in this wherein the charges move from a particular place where the charges are accumulated. It can be anything like battery or generator or transformer, for that matter. Transformer is a very big thing, but you can take it as for your understanding that the charges are moving from a place where they are accumulated to to a point where there are absolutely no charges. So mobile phones, like our mobile phones, do not have any charge, or devices do not contain any free electron charges. So the charges start flowing from higher potential to the lower potential. So this is about the electric current. So this whole flow of electric charges is called as electric current. So how we can denote electric current? So it is denoted by I stands for current. So uh, it is really helpful in our numericals. You have to remember it at what symbol is being used for denoting which physics terminology. Like I is being used for electric current, V is used for potential difference or electric potential, Q is for charge, and T is for time taken, and W is for work done. So you have to remember all these symbols as well as their physics terms, to their physics terms. Okay, so it is denoted by I. Now, what is the formula of electric current? Well, we have to find out what is the amount of electric current flowing in a particular device. So, electric current is equal to the amount of charges flowing, amount of charges flowing upon the time taken, that is in seconds. Time taken, now time taken means that the complete time that these charges take to move from point 1 to point B. So this whole process is called as electric current. So it can be denoted in physics terminologies. I is equal to Q by T. Q is the amount of charges and T is the time taken. So what are the SI unit of electric current? So let me write it for you. SI unit of electric charge is ampere. Now for the physics and for this physics understanding of this formula, by the by these SI units, so how we can denote it in the physics terms? Basically, it is the definition of 1 ampere current. In a very simple language, it is the definition of 1 ampere. So what is the definition of 1 ampere? Well, it is the amount of current means here electric current, huh? So you have to bear in mind that what is just current. Well, it is electric current. So amount of current flowing when 1 coulomb of flows charges flow from a conductor, or to be very precise, any cross section of conductor, any cross section of a conductor, and in 1 second. So the SI unit of time here in electric current is T, that is in second. Q, that is electric charges, is coulomb, and I is for current, it is ampere. So you have to bear in mind in 1 second. So there might be a possibility that that it might be a possibility that CBSE may ask this question, or even your e- in your internal exams this question may ask that define 1 ampere of current. So here you have to write is that 1 ampere is the amount of current flowing when one amount of charges are flowing from any cross section of a conductor. Well, what is cross section? So cross section is nothing but through a conductor, like it can be anything, wire of a light bulb, a fan, anything. So just you have to remember it as cross section of a conductor in 1 second. You have to write this 1 second because it is the amount of time. So how we can uh, you know measure this current? Current is measured by a device called ammeter. Ammeter. So ammeter is a device that is being used to measure the electric current that is flowing through a conductor. It can be anything, wire, light bulb, or any appliances. So ammeter is being used. Now ammeter, some important facts about the ammeter that can be asked in your CBSE examinations or internal examinations, that ammeter is connected in series. Now you might be thinking what is series and what is parallel. So we are going to cover everything like series, parallel, each and everything in our later videos. Okay, so don't have to worry right now. You just have to remember that emitter is connected in series. In the later days we will cover all these concepts in a very detailed manner. And okay, so emitter is connected in series, and it has a very low resistance, very low resistance, very low resistance. Okay, so due to this low resistance, it can't change, it can't change the value. Just a second, I'm sorry, I'll write it in a much more legible manner. It can't change the value of the current. Now for instance, if ammeter has a lot of resistance like voltmeter, then there might be a possibility that the current may not flow anything, like the current can't flow only the amount of resistance so much that the current can't flow only, and due to this the reading on ammeter will always be zero. So it becomes absolutely useless for us. So the ammeter's resistance should be very low and voltmeter resistance should be very high, and by this their usability increases. So ammeter has a very low resistance, and by this it can't change the value of electric current of current. Okay, so these are the things that you have to bear in your mind while you are studying, and also you have to remember it thoroughly, by practicing it, so that it really gets easy for you to understand these things. Okay, so there might be a question that what is the source of electric current? How we can get an electric current in our daily lives. So it's very simple. So the sources of electric current are, well, let me get, yeah. So the sources, what are the sources of electric current? Electric current. Okay. So what are the sources of electric current? So it might be a battery or a cell. Well, what is a battery? You have to remember it that battery is the collection of cells. The single cell that we see in our daily lives. Well, I don't have a cell right now, but I can show you a battery. Just a second, I'll show you a battery. So this is a battery. It is a camera battery, but this battery contains a lot of cells in it, and this accumulation of cells is called as a battery. So as you can see, this is a battery, and the cell is a single small cell that we use in our daily lives, in our remotes, or probably in other appliances, small appliances that contain that have a very small potential difference, or need very small amount of electric current. So what are the source of electric current? So a battery or a cell. Then second is a wall socket, wherein you can plug your devices and just get them charged. Okay. So next is that what is the direction of electric current? So this is a very important aspect when we are learning this electric current. We have to learn this in a very thoroughly, so that we don't lose our marks in our examinations. So the direction of electric current is actually depends upon the flow of electrons. So as we know that these electrons, second I'll draw it for you. Electrons have a tendency that they move. They have a tendency that they move from negative terminals to positive terminals, because obviously it's quite self-explanatory that they have a negative charge. So they do originate from negative terminal. So as they originate from negative terminal, they end up reaching the positive terminal. So let me write it for you. Electrons travel from positive terminal positive terminal okay. So electrons travel from positive terminal, yeah, from positive terminal to negative terminal. Oh, okay. I think I have done a mistake. No, it's not negative. It's not positive. It's negative, and here it is positive. So see, as you can see that even after completing my 10th, after 2 years, I also can make mistake. So you have to remember this thing, that electrons travel from negative terminal to positive terminal. And not only this, you have to remember each and every fact that is available in that is there in this chapter. So electrons travel from negative terminal to positive terminal. Okay. And because of their movement, the electric current flows in the direction opposite to the opposite to the direction of electrons. So as electrons are moving from negative terminal to positive terminal, the tendency of electric current is to move in the opposite direction of electrons. That is, they move from positive terminal to negative terminal. So current moves from positive terminal to negative terminal. You have to remember these things. Yeah, this is very important, as they can ask you in MCQs that which of the following is the direction of current. So it can be positive to negative, negative to positive. And if you don't know, or if you haven't remembered in a very in a religious manner, then you may end up forgetting these facts, and just select the wrong option and end up losing up marks. So you shouldn't be doing like that. Negative terminal. Okay. So we have come up to the end of the session, wherein we have learned the what is electric current, which is the flow of electrons from positive terminal to negative terminal, that is its direction. Then what are the sources of electric current? That is from where we can get free electrons. So it is battery or a wall socket. Then already we have discussed the direction of electric current, that is the electrons that flow from negative terminal to positive terminal. And this electric current flows in the opposite direction of the electrons. Okay, they have the habit tendency to that they flow the opposite in the direction of electrons, and current moves, that is electric current moves from positive terminal to negative terminal. Also we learned the formula of electric current, that is I is equal to q by t, wherein I is denoted by electric current, q is the amount of charges flown in 1 second, that is t, time taken. And what is the SI unit of electric current? Well, it is ampere. So guys, thank you so much for watching this video this for till here. I hope that you really understood what electric current is and its direction. And if you have liked this video, please give it a like, as well as subscribe to All About Studies, and also share this video with your friends so that they can also educate from this. And thank you guys for watching this video. Till the next video. Bye bye.